Heshbon Academy is the final lead to excellence in my academics.
My dear friends, do not fear any subject, including mathematics. Seek to understand it, and Heshbon Academy makes it easy for you. Make sure to subscribe so that you would not miss any of our tutorials.
Good day everyone, you're welcome to Heshbon Academy. So today we're going to talk about geometric progression. So what's geometric progression? If a sequence of number is such that the ratio of any term to the term just preceding it is constant, then the sequence is geometric progression or exponential sequence. What this statement means is that if the ratios are common, they are constant, we'll say that sequence is either exponential sequence or we call it geometric progression. So with that, let's move to the end term of a sequence. So all you need to know is that t subscript n is the same thing as your nth term. Then your a is your first term, which is also the same thing as t subscript 1. Your n equals to number of terms in the sequence. Your r is known as your common ratio. Now let's have examples to help us understand this better. The second term of a GP exceeds the first term by 4, and the third term exceeds the second term by 12. The question says find the fourth term. Now, I always tell students, once you have word problems, the first thing you're supposed to do is to turn those sentences into mathematical statements. So when you do that, it will be easy for you to solve. So for example, let's look at the first statement. The two sentences, remember they are joined with and. So it means a compound sentence. So the first one is the second term of a GP exceeds the first term by 4. So if you want to turn it to a mathematical statement, we have our second term to be t subscript 2 equals our first term is what? T subscript 1. And so that t subscript 2 equal to what? Equal to t subscript 1 plus 4. Then the second statement says that the third term exceeds the second term by 12. That is to say, our t subscript 3 equals to t subscript 2 plus 12. Since we have the first statement to be our second term, which is equals to the first term plus 4, using the n term formula, our second term is the same thing as well as for a GP, is the same thing as a times r. How did we get our a r? Already we know that the formula for n term is t subscript n equals to a times common ratio r raised to power n minus 1. If our second term, which means our n is 2, substitute 2 into that formula, you will discover that your t2 will be equals to a times your r raised to power, the open bracket, that will be 2 minus 1, close bracket, and 2 minus 1 is 1. So at the end we are going to have your second term, that sequence, to be AR. So already we know that our second term is our first term plus 4. So what you have there is your AR equals to A plus 4. If you move your A to the left hand side and is equals to 4, so you will discover we have our A is common. So when you move out your A, open a bracket, what will remain will be your R minus 1. If you open that bracket again, it will give you the previous step, which is AR minus A equals to 4. So when we get to this place, when you have two unknown in one equation, let's call it equation 1. We move again to the second statement, and the second statement is what? That our third term equals to second term plus 12. Already you will know that your third term is the same thing as your A times r raised to power what? 2. You know how we got that from the formula. You can also try to substitute yourself, you will get it. And then our second term is what? AR. So we'll say our A r raised to power 2 equals to ar plus 12. If you check closely too, you will discover that ar is common on your left hand side. So you move the ar out, open a bracket, what you will have remaining will be r minus 1. You close bracket and that will be equals to 12. And like I told you before, you will understand that once you have two unknown and an equation, you really can't move. So what you will do, you call it what? Equation 2. Divide equation 2 by equation 1. So that will give you your ar, open a bracket, r minus 1, close the bracket, divided by, that is the ratio, a, open a bracket, r minus 1, close the bracket, and that's equals to what? 12 divided by 4. And so you will notice that your r minus 1 is up and is down, so it can cancel out. It will divide it, that one will move out. And then you also notice that you have your ar over a can still cancel a. What you will have left will be what? Your r, because which is equals to 12 over 4 will give you 4 will go in 12. How many times? 3 times. So it means your r equals to 3. Substitute your r equals to 3 in any of the equation, but I choose equation 1. So you will notice that in equation 1 we have a, open bracket, r minus 1, close bracket, equals to 4. So if I choose to move my r minus 1 to the right hand side, that means I will divide both sides by r minus 1. So what I will have will be my a equals to 4 divided by r minus 1. Now our r is 3. So you have your a equals to 4 divided by 3 minus 1. So your a equals to what? 2. Because 4 divided by 2 will give you 2. So now to the question. To find the fourth term, substitute. What we need to do is just to substitute the value of r and a in any of the equation. You will get your answer. So since we have our our fourth term equals to a, r raised to power 3. So if you substitute your a is already 2, and then we have our r to be 1, to be 3. So once we substitute that, it's going to give you 2. Open a bracket, you substitute 3. 3 raised to power 3 will give us 27. Then 27 times 2 will give us 54. So with that, we go to example 2. The example 2, we have a question. It said the first term of an arithmetic progression are x. And then we have open bracket 3x plus 1, that is the second term. And then the third term is 7x minus 4. We close the bracket. The question says, find 1, the value of x, 2, the 10th term. Then the B question again. It said the third and the fifth term of a geometric progression are 9 over 4 and 81 over 8 respectively. Find, number 3 question there, the common ratio and the first term. Now since the first question, the 8th part question, is an AP question, so we will use all the principles involved in solving arithmetic progression to get the value of x and to get the 10th term. So already we know to get any term in an arithmetic progression, we use the n term formally for AP. So which is our t subscript n equals to a plus what? Open a bracket n minus 1, close a bracket d. Then in order to get the x now, so we can say, okay, our second term, what's our second term? Our second term in that sequence is 3x plus 1. So which is also the same thing as t subscript 2 equals to a plus, open a bracket, 2 minus 1 times the common difference. Remember that our a in that sequence is x. So if you substitute your x where a is, and then you put your x where a is, that is substitute for the first term, and then your 2 minus 1 is 1. So 1 times d will give us d. So we now have x plus d equals to 3x plus 1. So if you move the x to the right hand side, you will discover that we're going to have d equals to 3x minus x plus 1. And so take away x from 3x, 1x from 3x, you have 2x plus 1. That will give us equation 1. And then we move again to the third term in that sequence, which is 7x minus 4. So it is also the same thing as your third term equals to a plus 3 minus 1, that is in a bracket, times d. So if you do that, you collect like terms, what you will have is that your a, which is still has a value of x, is x plus 2d equals to 7x minus 4. So your 2d equals to 7x minus x minus 4. You move your x to the right hand side. And so you are going to have 2x equals to 6x minus 4. If you watch your 6x minus 4, something is common there. A number is common. And what's that number? 2. You bring out your 2. You are going to have 2d equals to 2. Open the bracket, 3x minus 2. Close the bracket. Divide both sides by 2. So you are going to have your d equals to 3x minus 2. You have 2 unknown in an equation. You are stuck there. So you just call it equation 2. So since if you look at equation 1 and equation 2, you will discover it is common difference, and it is d. That's your common difference. It means they are equal. If in equation 1 your d is 10, definitely because it's constant, your equation 2 must also be 10, which means they are equal. So we say our d equals to 2x plus 1 equals to 3x minus 2. So if you do that, you have your 2x plus 1 equals to 3x minus 2. If you move 3x to the left hand side, you move plus 1 to the right hand side, and then that will be 1. You have 2x minus 3x equals to minus 2 minus 1. So if you take away 3x from 2x, you're still going to have a deficit of x, which is minus x equals to minus 3. The minus will cancel out, and we have x equals to 3. Now we want to get common difference. We've gotten our first term, value of our first term to be 3. Now we need to get the common difference. So our common difference, we can get it from our T2, which is equals to 3x plus 1. Substitute x in equation 1. We have our equation 1 to be 2d equals to 2x plus 1. So just substitute x in that equation. You have your d equals 2 times 3, which is 6 plus 1. So 6 plus 1, that will give us 7. Our d, which is the common difference, is 7. Now we want to get the 10th term. Already that is with the formula, we have your t subscript n equals to a plus n minus 1 times d. So with that, you substitute just your n there. That will be give you have our a to be 3. We have our common difference to be 7. The 10 minus 1 will give us 9. So you have your T10. T subscript 10 equals to what? 3 plus 9 times 7. 9 times 7 is 63. 63 plus 3, that will give us 66. It means our 10th term of that sequence is 66. Now we go to the second one, which is geometric progression. We have our third term to be equals to 9 over 2. And then our fifth term is 81 over 8. Our third term, which is, if you substitute it into the n term formula, which is a times r raised to power 2 equals to 9 over 2. That's equation 1. And our a times r raised to power 4, which is 81 over 8. That's equation 2. So divide equation 2 by equation 1. AR raised to power 4 divided by AR raised to power 2, which is equals to 81 divided by 8 divided by 9 over 2. So if you look closely, you will discover that your R raised to power 2 is equals to 81 over 8 times 2 over 9. If division sign wants to change to equality sign, just take reciprocal of the number close to that. That is, take the reciprocal of 9 over 2. So what you will have is that the numerator will come down, become the denominator, and y the denominator becomes the numerator. So you have 2 over 9. And so that will give you r squared equals to 9 When you sort out that, it will give you 9/4. So you take the square root of 9/4, that will give us 3/2. So our r is one whole number, 1/2. That is 1.5. So from equation 1, we know that our a times r raised to power 2 equals to 9/2. So our a equals to 9/2 divided by r squared. So if you take the reciprocal of r squared, that will give you change the multiplication sign. So based on that, you're going to have 9/2 times 1/3/2 all squared. So if you watch that closely, that will give you 9/2 times 2/3 all squared. So you're going to have 9/2 times 4/9, and that gives us our a is equals to what? 2. So we quickly move to sum of geometric progression. We have 4 formula for calculating the sum of GP. Number 1 is S subscript equals to A, open the bracket, R raised to power n, and then we have minus 1, close the bracket, divided by R minus 1. You use this to find the sum of a GP when your R is greater than 1. That is your common ratio greater than 1. And then you have a number 2 formula, that's S subscript n equals to A, open a bracket, 1 minus R raised to power n, close bracket, divided by 1 minus R. You use this when your R is less than 1. The third one is X subscript n equals to AN. You use this when your R is exactly 1. Now some students will argue and said over years, we always have cases where you have R greater than 1. We have cases where you have R less than 1. What do we do when R is equals to 1? Then there is a solution to that, and that is number 3. You have your S subscript n equals to AN. You use this to find the sum of the series when your R is exactly 1. The fourth case is when your n is infinity, tending to infinity. So how do you do that? You have your what? Your X subscript infinity equals to A over 1 minus R. So let's go to example 1. Under the sum of GP, so the first question is, the first term of a geometric progression is twice its common ratio. Find the sum of the first 2 terms of the progression if its sum of infinity is 8. First of all, change to mathematical statement. That statement, we have our A is twice the common ratio, which means our A equals to 2R. And then we have the sum of the infinity to be 8. So which means we're using the formula for the sum of infinity, which is S subscript infinity equals to A over 1 minus R. So where we have the sum of the infinity to be substituted as 8 equals to A over what? 1 minus R. So since we know that our A is 2R, where you have your A, put 2R. And we're going to have 8, open bracket, 1 minus R, close bracket equals to 2R. That is, you kind of either multiply both sides by 1 minus R. Then that will give us 8 minus 8R equals to 2R. Move your minus R to the right hand side. So we're going to have 8 equals to 10R. And then divide both sides by 10. That will give our R is going to give us 8 over 10. When you simplify more, that will give us 4 over 5 equals to R. So with that, then we substitute, we'll go back again, and since our then our A equals to what? 2R. So substitute that, that will give you A equals to 1 whole number 3 over 5 when you substitute the value of R. So if you look at our R is less than 1. Our R is less than 1. You can say Your r is 4 over 5. It's less than 1. So but the question is, it says find the sum of the first two terms, that is your x2. So since r is less than 1, then you can use to find the sum of the two terms. It's going to be your s subscript n equals to a open bracket 1 minus r raised to power n close bracket, then divided by 1 minus r. Since your n is 2, just substitute the value of n into that equation, and that will give you 8 over 5 open bracket 1 minus open bracket 4 over 5 raised to power 2 close bracket, divided by 1 minus 4 over 5. And so when you simplify that further, you will discover that the two terms will be 8 over 5 open bracket 1 minus 16 over 25. You close your bracket. Simplify further, you have 8 over 5, that is 9 open bracket 9 over 25, and then because 1 minus 16 over 25 will give you 9 over 65 over 25, so divided by 1 over 5. So change equality sign, you take the reciprocal of the right fraction, that's over 5, which will turn to 5 over 1. So we have 8 over 5 times 9 over 25 times 5 over 1. So when you simplify further, you're going to have 72 over 25. 25 will go in 72 two times, the remainder 22. So your the sum of the two times is going to give a two whole number, 22 over 25. So the second question, under the sum of GP, we have the third term of a geometric progression is 360, and the sixth term is 1215. You say find A, common ratio, B, first term, C, sum of the first four terms. Solution. Third term equals to 360. To find your third term there, that will be A times R squared equals to 360, equation 1. And then for the sixth term, that will be A times R raised to power 5, that's 1215. That's equation 2. Now we just divide equation 2 by equation 1. So that will just give us A times R raised to power 5 divided by A times R raised to power 2, which is 1215 divided by 360. So the A will cancel out. Using indices, the law of indices, with that you will discover that we're going to have R raised to power 5 minus 2. So that will give us R raised to power 3, and that's equals to 243 over 72. We divide. You keep on simplifying. So until you, how many times will 360 go in 1215? That will give us 27 over 8. And that's, you take the cube root of both sides, and that gives us 3 over 2. R equals to 1 whole number 1 over 2. Substitute R in equation 1 to get your A. Once you do that, equation 1 is the third term, which is A times R raised to power 2 equals to 360. Substitute the value of your R, and that will give you A open bracket 3 over 2 close bracket raised to power 2 equals to 360. So once you have that, you have 9 over 4 times A. That's 9A over 4 equals to 360. And then your 9A equals to 360 times 4. Multiply both sides by 4, you have your 9A equals to 1440, and your A equals to 1440 divided by 9. So your A is 160. And so since your R is greater than 1, because your R is 1 whole number 1 over 2, and so or we say 3 over 2. So, and we are looking for the sum of the 4 terms. So, and we're going to use formula of when R is greater than 1, and that is S subscript n equals to A open a bracket R raised to power n minus 1 close bracket divided by R minus 1. So when you substitute the value of A, which is 160, you substitute the value of R, which is 3 over 2, you're going to have the sum of the 4 terms to be 160 open a bigger bracket, 3 over 2 raised to power 4 minus 1, close the bigger bracket. So you're going to have 160, open a bracket, 81 divided by 16 minus 1, close the bracket. That will give you 160, open bracket, 65 over 16, close bracket, divided by half. And so with that, what do we have there? So we have 160 over 1 times 65 over 16 times 2 over 1. So our S subscript 4 is 1300. With this, we have assignment on geometric progression. That is, in a geometric progression, number 1 question, you see it there. You see number 2. I've come to the end of this class. So look forward for other classes. And if you feel like you want to know more, please go to our YouTube channels and WhatsApp channels. You're going to get more